welcome back. Maybe you looked at absolute value, maybe you didn't. Maybe you struggle with factoring, so you're here to work on the factoring. Well done, kudos. Let's get right into it. I'm going to pick about 4 of them that I think are tricky that students sometimes need help with, and if you need help on the other ones, come find me. Get on the internet, whatever you need to do, but you are responsible to know how to factor using these methods. So let's look at it. I am going to choose to factor C, D, E, H, and I. Let's get it done here. So C is super famous. Should absolutely have known how to do it from Algebra 2, but if you did not, don't fret. I'm going to show you my method of doing this. There is the grouping method, which we probably went over in class, but I find grouping method to be more steps than I want to deal with, so I do mine this way. Mine is a rendition of the X method. I put fractions on the side of my little x's. I multiply the first and last number, and that goes on top. I put the middle number on bottom, and then here's where I get a little different. Because this first term is a 6x squared, I put 6x's in these numerators of these fractions. To be completely honest, I don't even draw the x. I just go straight to the 6x over and 6x over. And then I just remember this next part, which is the same thing you guys do for your next part if you do the grouping method. And find 2 numbers that multiply to negative 12 and add to a positive 11. Those 2 numbers would be a positive 12 and a negative 1. Multiply to negative 12, add to a positive 11. Now the last part where mine is different than yours, I am not doing grouping. I am simplifying fractions. Amounts to the same thing. I have 6/12. 6/12 reduces to 1/2. And 6 over 1 doesn't reduce at all. So now I'm done. Those 2 things that we just made are my answers, are my factors. So one of the factors is a 1x plus 2. And the other one is 6x minus 6. You went through grouping, I got the same thing. Good, because that's the right answer. Next one, going over to letter D. Letter D is a difference of 2 squares. We need to recognize there is no GCF. It doesn't look like a trinomial, so we need some other methods here. It would be a difference of 2 squares. And how I'll explain a difference of 2 squares to you is if you can write it as 2 things being squared with a subtraction sign between them, then it will always factor to the first one plus the second one, and the first one minus the second one. So if I can write this as 2 things being squared with a subtraction sign between them, and I can, if I just wrote this as 2x quantity squared minus 1 squared, that's the exact same thing. These are the exact same thing, and I fit that stipulation. It's 2 things being squared with a minus sign. It will always factor to the first one plus the second, and the first one minus. 2x plus 1, 2x minus 11. F is a difference of 2 squares. Let's look at E. E doesn't quite look like what we're used to. I mean, it's a trinomial, so it kind of reminds me of B and C, but it's a to the 4th power. So we can handle that. That's not a big idea. We can use what's called quadratic form because it kind of looks like a quadratic. So to do quadratic form, I'm going to do something called a U substitution. We will do this a few times throughout the year. It's a way to make a tougher problem less tough. So I'm going to do that. I'm going to say wherever I see a C squared, I'm going to replace it with a U. I'm allowed to do that. A substitution. In that same vein, then, if I squared both of those, I could say wherever I see a C to the 4th, I'm going to call it a U squared. So now I'm going to go over to my problem, and wherever I see these things, I'll make the substitution. So C to the 4th, ooh, I just said that's U squared. Minus 7. Ooh, C squared, I said that's just a U. Plus 12. Ooh, now this problem, we've handled this problem before. I can factor this. This would factor to U minus 4, U minus 3. Now these U's were this fictitious variable, this dummy variable we use to just help us do this problem. I'm going to back substitute now and say, okay, U isn't a real thing. U is actually C squared. So I'm going to factor those and call this C squared minus 4 and a C squared minus 3. And if you tried to end it right there, you'd be wrong. I wouldn't blame you because this is a tougher idea. But what we just made, this C squared minus 4, is a difference of 2 squares, just like the one we talked about before. I can factor that now into C plus 2 and C minus 2. So my final answer would be C plus 2, C minus 2, and C squared minus 3. That would be my final answer. Completely factored. Moving on to H. H doesn't look like anything I've ever seen before. That's from your point of view. Obviously, I've seen it before. But it's a GCF. If I'm looking at this, this has x to the 5 halves, 3 halves, and x to the 1 half. They all have an x to the 1 half power. So if I took an x to the 1 half power off of all of these, I'm using division. And when you divide two things, you subtract their exponents. So 5 halves minus 1 half, that's 4 halves. 4 halves, 4 over 2, that's just 2. I'd be left with an x squared minus 6, just x, right? 3 halves minus 1 half, 2 halves is 1, minus 7. And now that looks like those things we've been factoring. Part B, part E, we just factored. So I'm going to have an x to the 1 half still out there. And I want two things that multiply to negative 7 and add to a negative 6. X minus 7, x plus 1. That would be that thing all the way back. Okay, finally, the last one is a tough one. We don't see it all that often, but let's at least expose you to it. You've seen it before. It's not totally foreign. It's called a sum or difference of two cubes. We're not talking squares anymore, cubes. And kind of the same routine I gave you. If you can write it like this, it will factor to this. That works here. If you can write it like this, it will factor to this. How I handle the signs, I remember SOAP. The acronym SOAP is same, opposite, always positive. Same, opposite, always positive. So first, let's get it in the form. I need it to be something cubed minus something cubed to be able to use sum or difference of 2 cubes. So 27, that would be 3. G, that would be a G. G, 3G cubed is 27G. And 8 is 2 cubed. If I can write it like this, it will factor to, I'm going to read it here, the first one, the second one, the first one squared, the first one times the second one squared. Okay, so let's make that happen. It factors to, now that I've written it like that, the first one, the second one, the first one squared, the first one times the second one, and the second one squared. I went ahead and squared it. So now let's do SOAP. I need to figure out my sign. This sign is always the same as the sign in the problem. So minus. The next one is opposite. So that has to be a plus. And the last one is always positive. Same, opposite, always positive. Let's clean this up a little bit here. I will have a 3G minus 2. And then over on this one, if I squared this, I have to square both these. I would get 9G squared plus 6G minus 4. It's a tough one. Don't expect you to be experts at it, but you should be able to practice and get better at it. There's some factoring for you. If you have questions, check all the solutions. Bring questions to me. Kicking butt. Moving on.